Hello guys, welcome back to my YouTube channel. So today we are going to solve day 30 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Today we are going to solve problem number 1671, minimum number of removals to make mountain array. Okay, so you are going to learn a lot of new concepts in this video. Okay, so you will see how we are going to use longest increasing subsequence, longest decreasing subsequence, okay, and all this stuff. Okay, so by the end of this video you guys will find this problem as not that hard. Okay, so let's read the problem statement first. So you may recall that an array is a mountain array if and only if array dot length is greater than equal to 3. Okay, so why so for a mountain there must be one starting point, right, and there must be one ending point. Okay, so in between there should be one element, right? So only in that case it will become a mountain, right? So midpoint, something like that. Okay, so there can be multiple midpoints like this as well. Okay, so only in that case it will become mountain. Okay, so if they are just 2 points, then it is just a plain road. Okay, starting and ending plain road. So that is why the array dot length should be greater than or equal to 3. Okay, only then it will form one mountain. Okay, simple thing. There exists some index I with 0 is less than I is less than array dot length minus 1, such that, so simple means that there is some mid value. So till here you see that uh, all these values are increasing. Okay, strictly increasing, and here all these values are strictly increasing from this side. Okay, so here you see array of 0 is less than array of 1, and array of 1 same way is less than array of I minus 1 is less than array of I. Okay, and from here onwards if you see the values are strictly decreasing. Okay, array of I is less than is greater than array of I plus 1, and array of I plus 1 is greater than this one. Okay, so values are like this, first strictly increasing, and then from one point it is strictly decreasing. Okay, something like that. Okay, so this is what we need. So definitely there must be 3 points, okay, at least. All right, so given an integer array nums, we have to return the minimum number of elements to remove to make a nums a mountain array. Okay, so see this example number 1. Okay, so here 1 and 3. Okay, 1 and 3 is strictly increasing. Okay, and then from 3, okay, if you take consider this as mid, then here it is strictly decreasing, so it is forming one mountain, right? So the array itself is a mountain array, so we don't need to remove any elements. Okay, so clear example number 1. Okay, now see this example number 2. Okay, so this is my nums array. All right, so here from 2 this is decreasing. Okay, from 2 here it is decreasing. Okay, and then it is not strictly increasing. Okay, it is remaining same. Okay, so there is one case that we can form it like this: 2 and then 5 and then 6. Okay, 2 after 2 it's strictly increasing, 5 strictly increasing, 6 and 6 there is no greater element. Okay, so in this way they are increasing. There is one more way: 1 5 6, then it is also increasing. Okay, 1 5 6 they are also increasing here, right? 1 5 6 and 5 6, there is one more possibility: 5 6. Okay, it is also increasing, and 2 3 is also one possibility. Okay, 2 and 3. Okay, if I just consider this 2 3, okay, there are multiple possibilities like this, right? So 2 5 6 1 5 6 5 6 increasing 2 6. So we are going to consider the largest one only, right? And here if you see strictly decreasing, so here 2 1 strictly decreasing. Okay, 2 1 if I consider, it is strictly decreasing. Okay, and 5 6, okay, it's not increasing. Okay, 6 2 is decreasing, 6 2 is decreasing. Okay, and here 6 2 3 is not strictly decreasing. Okay, but 6 3 is decreasing, and 6 3 1 if I use, it is also strictly decreasing. Okay, so here I can form this in a 2 5 6. 6 is a midpoint, and 6 3 1 I can form this, or 1 5 6 and then 6 3 1. Okay, so 1 5 6 if I use, strictly increasing, and then after that 6 3 1. Okay, it is decreasing, so 6 is already used here, 3 1. Okay, so this in this way I can form, right, one mountain: 1 5 and then 6 then 3 then 1. Okay, so I am forming this mountain. okay, like this. So here you see strictly increasing, strictly decreasing. So we have to return the minimum elements to remove. Okay, so that is why I have to consider the largest case. Okay, the largest case 156, not like this 5 6 and 1, not minimum. I have to remove the minimum number of elements, so I have to consider the largest number of elements that I can include. Okay, so here 156, the longest increasing subsequence that I found, the length is 3, and the longest decreasing subsequence, the length is 3 for this one as well. Okay, so total length of this nums array is 8, right? Just calculate, total length is 8. Okay, so in this 8 minus longest increasing subsequence length is 3, longest decreasing subsequence length is 3. Okay, and here if I consider this now, so 156, here 156 and 631, so I am considering 6 two times, right? So I have to consider the 6 only one time, so here I am subtracting 1. Okay, so here what is the result that I am getting? 3 plus 3, 6 minus 1, 5, 8 minus 5 is equal to 3. So only 3 elements I am removing. Okay, so that is why output is 3. And what are the 3 elements that I am removing if I am using 15631? Okay, then I am removing this 2, this one, and this 2. Okay, so 15631. Okay, so this is going to give me the output. Okay, so I hope that you guys are clear. Okay, what is the approach that we are going to use to solve this problem? Right, now let's understand this. Okay, so first thing, this is my nums array, right? Nums array, and the length of my nums array is 8. Okay, and I have given the indexes, and these are the numbers that I have: 2115, 2115, 6231. Okay, so now what I have to do, I have to calculate the longest increasing subsequence ending at each index. Longest increasing subsequence ending at each index. Okay, E, I am writing E means ending at each index. Okay, so here now what we need to do. Okay, so let's understand that. All right, so here let's fill this LIS1. So initially I am saying let's fill all these values to 1. Initially fill this complete LIS to 1. Okay, so this is the first thing that you need to do. Okay, and then after that place my I at index 1. Okay, let's place I here. Okay, and now I have to run one more inner loop j, and j is going to run from 0 to less than I. So only for this element j will run. Right now my I is at this position, so only for this element my j will run. Okay, so now I have to update my, so here I will check if my 1 is greater than this 2. No, I am finding what I am finding strictly increasing. Okay, longest increasing subsequence, so I am finding strictly increasing. So here 1 is greater than 2. No, so at this index there is only one element, so here I don't need to update it anything. Okay, now what I have to do, my I is going to move further. My I reaches at this position. Okay, so at this index the number of elements which are strictly increasing ending at this particular index. So no, 2 after that it is decreasing na, 1 consistent. Okay, no need to consider. Okay, so no elements are increasing at this particular index, so here it will remain 1 only. Okay, now my I is going to move further. Okay, so now my I reaches at this position. Okay, now see carefully. So my I is at this position, so now my j is going to run from here to here. Okay, from 0 to 2 my I is at this position. Okay, so now I have to check if my this element 5 is greater than 2. Yes, my 5 is greater than 2. Okay, so now 2 is smaller than 5, right? So there is one element which is strictly increasing, right? 2 and 5 are strictly increasing, right? 2 to 5. Okay, so here I am just going to update my LIS of this index 3, okay, to 2. Okay, 2 and 5, two elements. Okay, so here I am going to update it to 2. All right, I have updated it. Okay, so now what is going to happen, my j is going to move further. Okay, so now from this position I have to check. Okay, so j and here 1 and 5, so it is also increasing. Okay, 1 and 5 is also increasing, but it is already updated 2, so it's not going to change, right? Because 2 is maximum as of now. Then my j is going to update here, j 1 to 5, it's cyclically increasing. Okay, starting from here ending at here, so it is strictly increasing. Okay, 2 5 2 elements, so 2 is there. Okay, this is done. Now my eye is going to move further next time. So now my eye is going to reach at this position next time, and j is again going to start from starting position. Okay, so j is going to start from here. Okay, starting from here, ending at here. Okay, this is what I need to calculate. So 2 to 6, it's increasing, it's continuously increasing, right? 2 to 6 increasing subsequence, right? 2 and 6, right? 6 is greater than 2. Okay, so here I am going to update it to 2. Okay, now after that I move further, my j is going to move further. Okay, at this particular index. Now see carefully here what I'm going to show you. Okay, so here my j is at here. Okay, so at this particular index 1 and 6. Okay, so here 1 and 6. All right, so here increasing, so it will remain 2 only, no update. Okay, 1 and 6. Okay, now my I is going to, j is going to at this position. Okay, so here 1 and 6, so here at this point two elements only, right? 1 and 6. Okay, so no change. Okay, now see what is going to happen. Now my j is at this position. Okay, so here what I'm going to see here at 5 to 6. Okay, but there is one more thing here I have to consider. At 5 I already see that there are the value stored here is 2, right? The value stored here is 2. That simply means that at this particular position I already see that there are two elements which are longest increasing subsequence, which are forming longest increasing subsequence. Okay, so here in this 2, now I have to add this 6, right? So 2 5 6 is going to form one combination. Okay, so here I'm going to update it to 3 now this time. All right, I'm going to update it to 3. Reason is simple. At this index I have to found, right? At this particular position I have to found. So I already aware that from here to here if I see, then only 1, because here it is 1 only. At this element 1 and 6. Okay, so 2 only, because the number of longest increasing subsequence ending at this particular index was 1 only. At this it was 1 only, so in 1 I am adding 6, so it is going to form 2. But when I reach at this particular position 5, I see that the value at LSI of this index is 2. Okay, LSI of j is 2. So in this 5 I am adding 6 right now. So 2 5 6 or 1 5 6, so it is forming one combination, right? So that is why now this value is going to update to 3. Okay, so what is the formula that I am using here? So here if I want to write that, so I am going to update my LIS of I as math.max of here LIS of I at that particular position. If it is already maximum, then don't need to update. Otherwise LIS of j. Okay, so here j value was 2. In this I am adding one element. Okay, so this is how I was updating, right? So this is the case. Okay, so this is how I am going to update my LS of I. Okay, now next time my eye is going to move further. Okay, here. So now here I want to use this 2. Okay, so ending at this particular index, longest increasing subsequence. So here I will see that 2 to no increasing. Okay, j is here, not increasing. J is here, that is it is increasing. Okay, so here 1 and 2, two elements, right? 1 and 2, add this 1. Now at this 1 we have to add 1. Okay, so here it will become 2. Okay, my j is going to reach at this position. 1 2 is increasing, so it will remain 2. Okay, now my j is reaching at this position. 5 to 2, no, it's not decreasing, it's decreasing, it's not increasing. Okay, so no update here, there is no update. Okay, this is done. Then after that I reach here. Okay, again I have to do the calculation, same calculations again. So again j is starting from here, so 2 to 3, this there is one combination, so you update it to 2. Okay, 1 to 3. Okay, 1 to 3 I'm updating, so 2 it will remain 2. 1 to 3 remain 2. 5 is greater than 3, no update. 6 is greater than 3, no update. 2 is greater than 3, no. Okay, so here I have to check it. So 2 and 3 is going to form one combination 2. Okay, so in the end when my eye reaches here, so again I have to iterate. So in the end you will see that this is going to be my longest increasing subsequence. Okay, this is how I am going to calculate the longest increasing subsequence. So here we are doing nothing but calculating the longest increasing subsequence ending at each index, okay. So this is going to my LIS in the end. 1 1 1 2 3 2 2 and 1. Okay, okay, here it's not 2, here it should be 3 now. Why 3? Here see, 1 2 and 3. Okay, so in this 2 I am operating now. So here 2 and 3 forming one combination, but at 2 I know that 2 was already stored, so here it should be 3. Okay, so it should be 3. So 1 1 1 2 3 2 3 1. Okay, so this is a code to calculate the LIS. Okay, simple thing. Now we have to calculate the LDS as well. Okay, so how I'm going to calculate the LDS? So here let me just erase it. Okay, erase all this stuff. Okay, so now we have to calculate the LDS. So LDS, how we are going to calculate the LDS? So starting from each index we have to find. Okay, longest decreasing subsequence starting from each index. Okay, S, here E, here S, starting from each index. Okay, so here I'm going to place my I at n minus 2. Okay, n minus 2 means here. From here I am going to start opposite. Okay, this time I is here and I'm going to place my j at I plus 1. So j is going to be here. Okay, so now I have to find the longest decreasing subsequence which are at this particular index. Okay, so here initially first do one thing, fill all these values as 1. Okay, so now add this, it will remain symbol element. Okay, 1 1. Okay, now I have to update this 3 and 3 to 1, there is one decreasing, right? 3 1. So here it is going to update to 2. Okay, 3 1, triple decreasing. Okay, then 2 3 1. Okay, so here 2 and 1 is going to form one combination, right? So here I'm going to update to 2. Okay, so but same way like LS, I have to do LDS. Okay, so I have to place my I here, then J is going to run. Okay, so formula for this one is LDS is LDS of I. I'm going to update it like this. LDS of I is equal to max of LDS of I and LDS of J. Okay, what is the value here? And in this I have to add 1. Okay, same way. So here 2 and here 1. Okay, now I move to this place. Okay, 6 2 1 is one combination of 6 3 1. So max length that I'm getting here is 3. Okay, I'm placing it here. Okay, then here 5 5 2 1 you can consider, or you can consider 5 3 1. Okay, these are the possibilities. So max but I'm going to get is 3 only. Okay, decreasing. So here I'm going to update to 3. Okay, and then I move here 1. So for this it will remain same only. If 1, there is no element which is smaller than 1, there is no element which is smaller than 1. Okay, so here I'm going to place 1 1 only, and here if you see 2, there is one decreasing 2 1. Okay, and yeah, there is only 2, so here I'm going to update it to 2. Okay, so this is going to my LDS. Okay, this is done. Now here one thing is fixed. Okay, one thing is fixed, that we need one starting point and we need one ending point. Okay, that is fixed. So we have to calculate the minimum removals required to make the array a mountain. Okay, so here what I'm going to do, I'm going to start my I from index I is equal to 1, and I'm going to run for I is less than n minus 1. Okay, so here this value is n minus 1, right? This value is n minus 2. Okay, so here I am going to run for my I is less than n minus 1. So inside this, okay, for LIS and LDS, inside this I'm going to check the max case. Okay, the max case, max mountain length. What is the max mountain length that I'm going to get inside this? Okay, we need one starting point, we need one ending point. Okay, in between we have to see, right? So that starting point and that ending point can be anywhere. Okay, so here I have to find the peak. Okay, we have to calculate the maximum minimum removals required to make array amount an array, right? So I as a peak index, we must have LIS greater than equal to 2 and LDS greater than equal to 2. Okay, so here here at this is 2 and 3. Okay, so 3 2 5. Okay, this, or we can use this as well. 3 3 3 3 is going to form maximum, right? 3 plus 3 is 6. Okay, simply means that three elements which are here. Okay, three elements like this and three elements like this. Okay, increasing, three elements increasing and three elements decreasing. Okay, so peak we will find here. So total length mountain is this, and here at this three elements, 3 is common. Okay, this is common, this 4 index is common, this 4 index is common. Okay, so that is why 3 plus 3 and minus 1 I am doing. Okay, so I will get the output as 3 for this problem. Okay, simple thing. Okay, now let's write the code. So with code you get better understanding. Okay, so here first thing, calculate the length of my nums array, nums dot length, and then after that step 1 is going to be the calculate the length of longest increasing subsequence. Okay, ending at each index. Okay, so here simple thing, create one LIS array. Okay, leave the same site, new int n. Okay, and here first thing, do this arrays dot fill, and we are filling what? We are filling LIS with which value? 1. Okay, this is done. Then we have to run two loops for int. Okay, so here now see carefully. Okay, now I am going to explain the code side by side. I am starting from here, starting filling from here. Okay, so at here only one element is there, so only one, it will remain one only, so we don't need to start from here, we are going to start from here. Okay, so for int I is equal to 1, I is less than n, I plus plus, and here inside this j is going to start from 0, and j should be less than I, and increment j. Okay, same thing, simple thing, right? And inside this, if strictly increasing, so my nums of I should be greater than nums of j. This is what I need, right? Okay, so if this is the case, then only I have to update my LIS of I index. So how I'm going to update it? I'm going to update it like this, math.max of LIS at that particular index. Okay, if it is already maximum. Okay, we have already calculated the max value. If we didn't calculate the max value, then take the value from LISJ. Okay, starting at that particular index. Okay, so my j is here. Okay, for 6 that I was calculating, so I was checking LISJ at this position and then adding 1. Okay, so here LISJ plus 1, simple. Okay, so that's it, that's it. Okay, so this is for, let me just format it. Okay, so this is for calculate the length of the longest increasing subsequence ending at each index. So this is ending here. Okay, and now we have to calculate the LDS. Okay, so here let me just copy this. Code is going to be very simple for this one. Okay, so now step 2, calculate the length of the longest decreasing. Okay, so here decreasing subsequence starting at each index, starting at each index, starting at each index. So here let's change it to LDS, this small, let's keep it small, LDS, and here I is going to start from, we already know this value. Okay, so decreasing at this index. Okay, from here decreasing, so we don't need to check this, we are going to start from here. This value is not, this index is nothing but n minus 1, this index is nothing but n minus 2, right? So here I is equal to n minus 2, and I here I am going to write should be greater than equal to 0, and here I have to decrement I. Okay, and if my I is starting from here, my j is going to be at this position, which is nothing but I plus 1. So here I have to write j is equal to I plus 1, right? And j is less than n, here j should be less than n, and here j plus plus. Okay, here same thing, and here I have to update my LDS. LDS of I is equal to math.max of LDS of I, and here LDS of j plus 1. Okay, that's it, that's it. Okay, we have Now let's move to step 3, which is going to be final step. That's it. Code is done. Step 3. Calculate the minimum removals required to make the array mountain. Okay, mountain array you need. Okay, so now what we need to do here inside this. Okay, so max mountain length, int max mountain length is equal to 0, and after that let's start from index int I is equal to 1 and I is less than n minus 1. Okay, and here I plus plus. Okay, so here what we need I as peak index. Okay, I as peak index. So we must have LIS greater than equal to 2 and LDS also greater than equal to 2. Okay, we need that. Okay, so but we will not get this at this particular index, right? LIS we will never get longest increasing subsequence ending at this particular index. So this is a starting point, so it will always remain 1. Okay, and same for LDS longest decreasing subsequence, it will always remain 1. Okay, so we can't use that. So that's why I'm checking from middle ones only. Okay, we will get the maximum value in the middle one only. Okay, the combination of these two which gives the maximum value. Okay, so for that purpose I'm going to start from the I'm running from I is equal to 1, I is less than n minus 1. Okay, so here if let me just format it first. Okay, this is done. Okay, if here LIS of I, okay, is greater than 1, we need greater than 1 always. The reason is simple, because mountain length should be greater than or equal to 3, right? LDS of I should be greater than 1. Okay, then in that case let's calculate our max mountain length. Okay, so max mountain length is equal to math dot max of max mountain length. Copy this, and this you guys already know, right? LIS of I plus LDS of I minus 1. Why minus 1? Because there is one common element, okay, when we are doing this. All right, now in the end, okay, here this for loop ends. Now here just one line, return and minus max mountain length. Okay, so now let's run it and see if there are any code issues. We will try to fix that. Wonderful, so all the test cases has been accepted. Now let's submit it. So what is going to be time complexity for this problem? Let's see. So time complexity is going to be of, I'm going to say of n scale, you can say, right? Okay, why we are, because we are doing nested loops, right? We are running nested loops for both LIS and LDS, right? Here, so time complexity is going to be of n square. Okay, so I hope that you guys are able to understand today's problem. If you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.